Yes, sir, I am here.
Okay, okay. So I think I have already made you the co-host. You can start, huh? You can start the session.
Okay.
And that,
I'm sharing.
yes, yes.
Yes, I'm sharing
And
the.
recommend many students having that complaint that you have not given the access, public access to that Google Colab.
Oh, okay, okay. I'm giving you the
Give
access.
the
So I'm forgotten that I'm just there. That. Okay, I'm giving you the access again. I'm giving you the link. Uh,
fine,
link.
fine. You can start.
Okay. Good morning, everybody. Let's start this. I think I am. The skin is showing to you.
Yes, yes, yes.
It's first of all, you said me that I have not shared the. Here is the PPT. Yesterday we discussed about the classifiers and we implement the whatever we learn the 4 ML model, basic ML model. We implement with this COVID dataset as well as the fraud detection dataset, credit card fraud detection dataset. So today we'll discuss about the regressions, and I implemented two assignment now. One is the crop price predictions, okay, for a month, crop price prediction. Another I will discuss about a simple ice cream price prediction. Since it is summer, let us discuss ice cream price predictions. Okay, first of all, we'll go to the crop price prediction. This is the data set. So the data is given the all state of India from 2000 prices. Okay, the data set contains the historical crop price of all state of India from 2010 to 2025, and the data set contains the features as crops type, date of price, minimum price, maximum price, average price. This thing is given to you, and the we can take here the average price as the predictions for the when you give the crops type and date and minimum price, maximum price, then average price will show to you for a month for some crops. So uh, I already download the data set using here this one, and the data set is like that. It is like this. First one is your date, okay. Second one is your commodity name. That means crops name, maize, on wheat, all that is there. Then next one is your average price of that crops on that month. Then is your average minimum price. Then this one is average maximum price. Then it is of state name is not given, all are given the India, okay, all are given the India. Then district also the same, all district is written. And calculation, whatever calculation is done based on your monthly values, okay. So all are your monthly values. Then your change, what is the change found in your price is written here. So with this features value, we need to find out what will be your price for a month. If you give this commodity name, date, and average minimum price, average maximum price, then what will be your average price of the cost for the month? Okay. So with this data set, we'll do that one. And to since price is your continuous data type, so we need to use the regression. Okay, we learn four type of regression. One is the linear regression, another is the k nearest neighbor, third one is your decision tree, fourth one is your random forest. Okay, here you are not using the logistic regression because logistic regression is special classification. This is for implementations. I already done this one because if I'll write the code here, then it will take too much time. So as I said you in previous classes, first of all, you will load this data set. Since the data set is not very high, so I just instead of giving it in the Google Drive, and I'm here giving here directly upload it here. So when this box will come, this data set, I just click here and open it, and it is 100% merge here. Then what is the information about the data set? You see here, okay, and this is the average price that is floating. Average minimum price is your also float value. Average maximum price also float value. State name is object. District name is object. Calculation type is object. Change how much change is that. This is not missing. So, you can take also this one as the target value. How much change is there in if you taking the model average model price and the minimum price, maximum price. What is the change? You can take this one also target value. Okay. So here, since these are what is the value here? First of all, if you see the information about the data set, you find that when you do this one minute, this one, df describe set is 2,810, and from 0 to 1,809, and here you find 794. Other thing you need to know what is giving you this, or this one, unique values. the unique value. Month is given all the date. Okay, date is also repeated or may not repeated. Then when you consider the value of the commodity name, it is coming maize, wheat, rice, sugar, cotton, coffee, tea, soya. Then the data is so for more data is there. It's just omitted some middle data. It's just given last three data and first three data. Is for all numeric it is given. And state is, you see here, for the state it has only one value, India. And for the district, from the district you find also one value or, and for the calculation type only one value monthly. So for your predictions, for the predictions, you not needed to consider this one. This is state name, district name, and calculation type, because all are of the same. So you need to drop these values. Okay. So I dropped this one. I drop here state name, district name, and the calculations type. So after dropping this one, you will find rest of the column. Okay, unique is written, so you will get rest of the column informations. See here, when you do the informations, these are all omitted. Finally, when you consider the information after dropping, df dot info, you find here that those three items are the offset. So you need to convert it into the level encoding or something you need to do, or order encoding, level encoding you can do. So for that, I did here all this pre-processing, then import the level encoder class, then I create the instance of the class, then I run this one. Which will make it the new. So another thing is that 2794 is your not equal to 2810. That means some amount of data are missed. Okay, so we need to remove. We need to consider that one. Where is it? It's not saved by then. Okay. So how to do this one? You will write here the code. That is your df is your chains is equal to you need to input that one. One. dot fill df. That means you have give the mean value for this average value, whatever the data is null data. You can taste, since it is here 2794 to 8, this you can taste whether there is any null value or that by command. I already explained you how to taste whether there is null or not. You can use that command and you can find out whether there is null value or not. Okay. So since I am just analyze it and find out that this is 1810 instances, what here it is showing 2794. That means 16 in some instances are not present. So I do this one. So here was open, your null value is replaced. Now informations. Now if you seen the informations, that is df dot info, you will find that all are numeric data, all are filled. Suppose I want to predict the average price for the uh, commodities. Okay, so I have taken here, this one is your this one is your target data. All others are, I have taken the features. So here we have the 5 features, one target data. Then I'll do this one. First of all, I will differentiate the data from X is from features to target data. X df dot drop. You will track the drop price. Okay. Here is not price, here written as the average modal price. So you have to write here average modal price. I should import, I should split the data set as the taste data set and the trend data set. So what was the command, that one? From sklearn, you will use this one. From the sklearn model selection, import train and taste split. Okay. So then you will use this one for the splitting. That is, so what was the command? Xtrain, xtaste, xtrain, xtaste this. And here also I have taken 80% data for the training, 20% data. You can take 70% for the training and 30% for the testing. Then after running this, okay, regression model is what was the model? From sklearn dot linear model. Okay, import linear regressions. Okay, linear regression, then metric. You need to find the mean square error. Another, you can find the mean absolute error also. Mean absolute error you also can find here. Okay, so next, So we create the instance for the linear regression. That name is you have given the model, and model.fit you will train the model using the training data set. Then for the testing data set, what will be the prediction using this model is found out, and real output is this one. Your output, your model output is Y predict. Okay, so if you run this one, it will show. Now, of course, you can find a mean square error or two square score mean square absolute error. Okay, so MSC is equal to mean square error. This, so when you print this value, it will show you print. Okay, all this thing is displayed to you. So when you run this one, it's showing that the mean square error is this much, and the mean absolute error is this one, and your R square error is this one. Okay, it should be too. It should be very high error. This model is not acceptable. It is approximate to 0. Okay, it should be approximate, and R square is equal should be 1. Then only it will be a good model. Okay, next we'll implement the k nearest decision tree. We'll do decision tree because k nearest neighbor will take more time. We'll not go to that. We'll go for that. Then now we'll consider for the decision tree. So here is the tree. The command is here is tree. From the tree, you have to what is the decision tree model name was decision tree. Since you are using the regression, so you have to, if it is classify, you have to write the classifier. Since it is regression, so now you will create the instance of decision tree regressions. Okay, so when you run this one, you find that the error, mean square errors is 6,10,098. We should be 98, above 98. So it should be 0. Approximately 0 is acceptable. This one is 119. This is also very high. Okay. So comparative to this regression, this one is better because it is, you see here, this one is very high, very high. It is 1071 or approximately 72 lakh. This is not in lakh. Is 6 lakhs, only 6. 6 or say, approximately 6 lakhs. So one. So the comparative to regression, decision tree here given the better performance. Let's go for the random forest. Selection problem, you don't have to. So ensemble, it is defined, random forest is defined in the ensemble file. So you need to write here ensemble. Then what is the class name? Random forest regression is the class name. Then you will do only you have to change here. You have to create the instance of this class, random forest regression class. Then all other things is set. Okay. When you run this one, you find here that this is your 3,90,000. This is 77, and this is very nearer to 1 also. This one also nearer to 1. So you find here random forest has given the better performance, because here 6 lakh 10,000, here is 3,90,000. So it's given better result than this is 119, this is 77. So here we find that from the regression, decision tree has given better performance, from the decision tree random forest has given better performance. Last one is your k nearest neighbor. So let's do this one. This is your neighbor. Here is the file name is neighbors, and the class name is your k nearest. K regression. Then you have to create the instance of the k neighbor, k nearest neighbor. K regression. Okay, then you run this one. So see here, it is your this is your 4,51,280. Absolute error is 79. This is also very near to R square is also. But here we find that this is better. R square is better in the random forest. 77 is better in the random forest. And this one 3,90,000, this is 4,00,000. So you find here that among all these four, you find that the random forest has given the better. But this is not a good model. It's not a good model even. You cannot directly deploy it. You cannot believe this one, because error is very high. 3,00,000. It should be approximately 0. Okay, you can take 0 point something, even not 1. 0 point something is, if there 0.000 something is will be there, then only you can accept this model. Or 0 point something is acceptable. But if you are taking some value here, that means there is error, too much error. Okay. So this is about your implementations of the crop price prediction according to this features value. Okay. So this features value may not be suitable, but for our practice, this data set is given to so much data set is here. You can search and find out. This data set is given to you for the practice, the machine learning approaches. Okay. So these are very basic approaches. You need to know much better. There are so many vector approaches like support vector machines, and the deep learning approaches is there, and some ensemble approaches is there, that is XGBoost, AdaBoost. So many approaches are there. You may apply all this here also, and you may get better. Next to okay. So this was any doubt here? Any doubt you
You
have?
can unmute. You can unmute and ask the question.
No doubt.
So both the data set I discussed. Now one data set is one.
No, both very less amount of data set is there. I can cover that one only 15 minutes.
Okay. Then you just make
If you
all these 3 or 4 data set public this scholar so that they can do it
go through that.
uh,
Okay. Okay, I will make it for access.
to public. Yeah.
Okay. So let's go for the next one. Ice cream price prediction, since it is summer. Resource. It's a very simple data set. No, only one features is there. One is your target features, another is your prediction features. Okay, you can use here the polynomial regression, but we did not learn about it. We only learn the linear regression, how to generate the linear regression. So when you go do the advanced and do more other machine learning approaches, you can learn this one, polynomial regressions. Okay, so here only two features is given. One is your target features, another is your independent features. The independent features is your temperature. Okay, and according to temperature, ice cream will be sold. Okay. The fast data, some past data is there, very less amount of data here also there. You go through this data description, you can find out. Oh, it's not given any information here. You can download the data set and see this one, how many instances is there and what are the data is. You can go. Otherwise, you can study here also, given all this information here. Not all data is showing, very less amount of data is here. So the here it is given what is the temperature and correspondingly how many ice cream will be sold. Let's see how we implement this one. This one is very simple one. So first of all, I'm importing the file, ice cream data file, which is downloaded here. Okay, using this one or this one, I have downloaded the data set, and the data set is here. This is your temperature is given. Okay, it's only 50 data, 49 data. Okay, 49 data is here. Okay, and this is your ice cream cells unit, and it is given in the decimal form. You can round it and find out how many is set. Okay, finally, when a new floating value will be given to you or real value is given to you in the decimal form, you can do the roundup. So see here is showing this box. your system. So now this file is imported here. Then what is the information about the file? See here. You have the temperatures, 49 data is there, and correspondingly ice scheme, number of ice scheme 49. All twos are the floating point. Next, you have no problem. So you directly can use the linear split the data set and use the model to train and taste. So here the data set, first of all, I differentiate the temperatures from the ice cream because it is one form here. So dx is equal to df dot ice cream cells units. I drop this one. And y is your target data, number of ice cream cells. So it's kept here. Then I splitted it into the 20 and 80 ratio. Then I create this linear regression instances here. And then I feed the model with the training data set and find the model. And this will predict for the X test. Now you will consider what will be the performance. For that, you need to do same way here. Here you have done. So just have to copy here. Okay, next we need to apply that function to find the result. So this is from here. Okay, then run this one. So 49, this is mean absolute error is again. Still the error is very less. You can think you may accept and not accept. According to situation, if it is a very critical situation, medical case, you cannot take the risks. Okay, so in that case, you need to do too much analysis. And if it is yes, if any fault will happen, it's okay, it is manageable. Then in that case, you may apply. So it is depends upon the domain where you are using the this models. Accordingly, so many things is fixed. Next, we'll use the decision tree. Let use the decision tree. Then the random forest. Then it's not applicable because you only have the temperatures. Only splitted. How it is splitted? One depth will be there. We will take the value from some value to splitted for the regressions. So here for the temperature, how to split, if it is the floating value, how to split this one, there is so many mathematical technique is there. Correct. I already explained you, I think, in the theoretical part. So using that one, it will, the depth of the tree will be one here. Only one time it will be split. Okay. Generally, tree will be used for when there is some amount, minimum amount of features must be there. Since only one features is there, one depth will use to split. So let us use the decision tree. I'm directly going to here since I already did this one. So I'm doing the copy paste. Okay. Better given than here. So all is better given than here. Okay. So next we'll consider the next we consider here this one is your random.
Ma'am is joining soon. Some net issues are there.
Yeah, sorry, very sorry. Due to some problem, line problem, the network problem. Sorry. Okay, so here we are discussing about the implementations of ice cream. This one I already discussed how random forest is implemented with this. Then when I run this one, we find that the mean square error is 18 point something, I mean absolute error is 3 point something, and the R square error is 0.8. So it is random forest and the decision tree, since only one features is there, so is showing this such a manner. So it is not applicable. Still, decision tree is okay, but the random forest should not be used here. Okay. Next is k nearest neighbor. It is appropriate matter. This data set is not suitable. So let's regression, linear regression is okay, but decision tree is giving better performance. Let us go for the k nearest neighbor. Hello.
Yes, ma'am. You are audible.
Any problem?
No, no, you are audible.
Any,
I am muted. I am muted. You can continue.
just do you find here the mean square error is 10.85, absolute error is 2, and the R square. It is same as the decision tree. I think no, decision tree is not giving the better than that. So k nearest neighbor is giving better. So among this four model, you find that the k nearest neighbor is giving the better performance. Okay, is it can be used to predict the price of the number of sale ice cream for the uh, according to temperature. You can deploy this model when the temperature is this one. How many ice cream will be sold? You can predict. Okay, this all about your regressions implementation of ice cream. So today we discuss about the crops price and the ice cream sales, number of ice cream sales. So, so I need to share this one. Okay, I'm sharing now only. About the clustering, then we jump to the artificial neural network, okay, which is trained to your deep learning. Artificial neural network is interpreted as a basic machine learning approaches, but when we have to consider more about it, more deep on it, deep learning, neural.
So when clustering will start? Monday.
Yes, Monday we may start
Okay.
at the same
Yes,
time,
yes.
11.
And you
I'll be
just
in the
share
call.
all these four Google Colab access as public.
Yes, I have shared to you the crops. This one I am
Now make it public so that student can access. Okay.
sharing you immediately.
Okay, I'll share it again. You just send the another two today. Yesterday you had sent to
Okay, so this today I have completed.
any doubt you can ask. Otherwise, you just implement. Then only in the next session you can ask your doubt. Okay. And from Monday we'll start the unsupervised learning clustering. Fine.
Clustering and then go to the neural network,
Yes.
deep learning basics.
Okay then. Thank you. Huh? Bye.
Okay, sir. Thank you, sir.
Just
Thank you.
share. Huh? Sure.